Okay, so we're going to start with the review. So number one, let's see how we're going to do this. Explain the relationship between ratio, decimal, and percent. Somebody say part of a whole. What else?
Part of a whole makes sense.
Ratio. What is ratio? What ratio means?
Ratio means that it represents like it represents the shaded part, right?
Yes, somebody said fraction. That's right. Ratio is fraction. Yeah, whole part of a whole. Yes. So what is decimal? What is decimal? Okay, give me example of ratio. Give me example of fraction.
A example is basically like 3/5.
3/5. Yes, somebody said 1/3. That's right. 3/5. Let's do that. 3/5. Okay, what is decimal? Decimal number. Which one is a decimal number? Give me example of decimal. Somebody said 0.75, 0.25. Yeah, that's right. Like 0.75, it's example of it. Okay, example of decimal number. What is percent? What is a percent? Divide anything divided by 100. Okay, you give me example, 60%, 10%. That's right. So I'm going to just use 10% here. So that's example of percent. You have this symbol. Percent means out of 100, right? Okay. So now these are the examples of ratio, decimal, percent. So then we have to give equivalent example of each. So what that means, you have to give you, if I give you a fraction, can you go to decimal? And can you go to percent? Can you go these three different things? So can you change, the question is, can you change fraction to decimal to percent and all the way back and forward? Can you do that?
Yes.
Okay, so I'll give you a fraction. Okay, some other people say yes. Okay, so I'll give you, or let me give you a decimal number. So let's say the number you have is point. So let's say 0.22. So 0.22, can you change it to fraction?
Yes.
What is 22 is how many, what is fraction form?
Fraction form is, isn't that when you, let's see.
Somebody say 11/50. How you get that? That's correct. How you get 11/50, Zane? How you change fraction, decimal to fraction?
I put 22 over 100.
Yes, good job. So 22 is 2200. So you put 22 over 100 and you reduce that. So it's the same like 11/50. Okay, so this is the fraction. This is the decimal. Now, can you give me the percent? How you get the percent? How many percent is that? If I have 11/50, or if I have 0.22, how many percent is that? Oh, somebody said 22%. Yeah, that's right. So it's going to be 22%. And if you write it as a percent, you have to put the percent symbol. So everybody know how to change the percent to decimal, decimal to percent? Yes, move to decimal 2 places to the right. Yes, that's correct. Okay, so these are the 3 different things you need to know how to change from one to another, okay? Okay, the next question is, which of the following ratios can be written as a percent? So if you travel 55 miles per hour, can you write it as a percent? And just read all of these four and just tell me which one is yes, which one is no. So if you travel 55 miles per hour, can you write it as a percent? Okay, somebody is giving me the answer for the second one. So can you change 55 miles per hour to percent? $21 students, yes or no? No? Okay. How about the next one? 21 students pass a math test out of a class of 24. So if the question is how many pass, yes, you can write it. How you can write this? You're gonna get the fraction, right? So it's gonna be 21 pass, or you can find how many fail. So how many pass? 21 out of 24 pass the math test. So what is that in percent for? What you need to do? You can just divide 21 divided by 24. And then that's the decimal form. What is the decimal form?
It's like 0.875.
That's right. And what is the percent from 0.875? How many percent is that? You move the decimal 2 places. So what is that? 87.5%.
Yeah.
Okay. Everybody understanding that?
Mm-hmm.
Okay. Now, 195 calories in donut. Can you write the percent of that? We don't know. Not exactly, right? We don't have information. It's not part of a whole. So I can do that. Earning 2 hours and 24 minutes towards your exam 1 lab requirement. Can you do how many percent? Can you do that?
Yes.
Okay. So how you do that? How you get the percent here? 2 hours and 24 minutes. How many? You need to change it to minutes, right?
Yeah.
Out of 200 minutes. So what is 2 hours and 24? So 2 hours is how many minutes?
2 hours is 120 minutes.
120 and 24 more. So it's going to be
144.
44. That's right. Now it's over 200. So if you want to get the percent, I need to divide up and down by 2, right? So I need to get it over 100.
Right.
So what is that?
72 over 100.
Yes, which is 72%. Good job. Okay, everybody understanding this question? Okay, let's go ahead. Let me see what I have. Okay, I have people answering this. Okay, good job. Yes, answer it in the chat. Good job. Okay, going to number 2. So looking at number 2, can you find the errors and explain how to fix them? So Luis left a $5 tip on a 22.70 check. Then the percent tip he left is, how are you going to calculate the percent? How many percent tip he left?
You would do 5 over 22.70 instead of 22.70 over 5, right?
So you have to do divide backwards, right?
Yes.
Good job. That's how you do it. And when you divide 5 by what you get? 22.7. How many percent is going to be point? I'm going to round. It's 2, 2, and 0, and 2, 6, and so on. So I'm just going to put 0.22. So how many percent is that?
22%.
It's 22%. That's right. Good job. So
Yay.
that's how you do it. That's how you fix it. And here, what is wrong? He divide. I mean, with the example they have, they divided backwards. So be
Yeah.
careful. You're going to have examples like this in the test where you're going to give you something wrong, and you have to fix it. Okay. The next one. What is a population proportion? Sorry, not population. What is proportion? And how you recognize that the problem can be set up as a proportion? And then make up a proportion problem. So what is proportion first? Do you remember
So
what? Yes, go
a
ahead.
proportion is an equation of the form ratio equals ratio. So A over B equals C over D, and then you would cross multiply, correct?
Good job. Yes. A over B equals C over D. That's the proportion. You have fraction equals fraction. Technically, that's what that it is, right? And how you solve it, you're going to cross multiply to solve it. Yes. So you're solving it when you multiply across AD equals BC. And then you solve whatever you're solving for. Okay, good job. That's a proportion. Now, can you make up a proportion problem? When problem can be solved with proportion? Give example of something you can solve with proportion. Nobody?
So 15 over,
Okay, you're just giving, okay, so you're just giving example, 15 over something, right?
yeah, 15 over like C equals like 2 over 2.4.
Okay, so this question, we're gonna leave it, we're gonna work it in groups, okay? So let's do that. Okay, somebody said, okay, good job, Zane. So if a car moves at 60 miles per hour, how far will you have driven after 4 hours? So how you set up that proportion? 60 hours, 60 miles for 1 hour. And the question is X over 4 hours, right? So, and you solve it like that. That's a good example. Yes, good job. So if a car, I'm gonna copy that and no, I can't post it. Can you guys see my chat or no? When I share my screen? No? Yes? Okay. So yeah, that's a good example. Thank you. So we got that. Okay, the next one is number 4. In 2018, only 551 and 73 people voted out of the 1 million and somebody, I mean, big number, registered voters in Bear County. If 1,300,000 people are registered, predict how many of them will vote. So if you have how many registered, how many vote. So we have to solve it. You can use proportion or how you want to solve this. How you going to set up equation to solve it? Any ideas? And they ask you to use another method to solve it, but let's do it with one method.
Proportion.
Proportion. So what you're going to put in the top?
So 551,073 over 1,073,000, or hold on.
Over
Over
1,073,000.
yeah, 1,073,320.
Okay, equals
equals X over 1,300,000.
Good job. That's right. So here, when you set up the proportion, you always have to keep in mind, you have to keep the units. So in the top, you put how many voted. In the bottom, you're going to put how many are registered voted. Registered to vote. Okay. So keep that in mind always when you set up a proportion, you have to keep the units in the top, the same units, in the bottom, different units. Okay. You have to be consistent with that. And just solve it. How you solve it? What's going to be X? You cross multiply. So you multiply those two numbers and divide by the number across. So multiply these two and divide by the number across X. So I'm going to write here how you get the answer. So it's going to be 551 and 73. You're multiplying by 1,300,000. And you divide it by 1,073,320. And what you get?
456.956.
Oh, so it's not a whole number, right? So let me do it so I can see. Okay, you're dividing by. Okay, so now if you're talking about decimal, we're talking about people here. So we have to round it, right? So it's going to be what? 667,000.
Yeah.
For
57, right?
50, let's say 56.
Oh, 56.
I know next number is, I mean, technically when you round in math is the 67, but okay, so technically when you have, so this is the rule we're gonna follow. So if you have solve an equation, so let's say you solve an equation and you have to do these numbers, you multiply 551,073 times 1,300,000 and divide by 1,073,320. So if you do this math for just equation, and you have here technically you have 667,456 point something, 0.9. If you solve an equation, then you're going to round 457. But because we are working with word problems, you have less than a person. Okay, so you don't have enough to complete a whole person. Make sense? So that's why it doesn't matter what you have after the decimal. So the decimal point was here, right? And doesn't matter what you have after the decimal, you just cut everything after the decimal. Because when you have a word problem where you're talking about people or books, like you're not going to publish half book, you're going to publish, let's say, a whole book, right? So every time when you deal with application where we're talking about something real, like a machine or something, depends what the problem is, always just cut. That's what you're deciding for this class. Cut it off. Everything after the decimal, forget about it, okay? Even if it's technically, if you round, you have to round to 457, but because we're talking about how many people are going to vote, then you're going to cut it off, okay? Make sense?
Okay, that makes more sense, yeah.
Yeah, everybody understand that? Okay. So that's going to be the rule for rounding. If you just solve equation, like they give you solve this equation and find X, and round 2 decimal places, for example, or round the whole number, for example, then you technically going to round to 457. But because it's solving actual application, we're talking about real people here, then you're going to round to 456. Make sense? Okay, going to the next one. Name 3 units data part of the metric system. And then name 3 units that are part of the imperial system. So give me 3 metrics. Do you guys remember this? What is it? Meter, liter, gram. Okay, good job. Meter, liter, and gram. Good job. And give me imperial 3 units. Foot, gallon, and pound. Good job. Foot, gallon, and what else? Pound. Right, LB. Okay, everybody good with that? Okay, so describe 2 ways you can perform conversions with the metric system and give the example using each. So if you convert different units within the metric system, how you do that? You technically move the decimal, right? So give me example. And they say use 2 different ways. So give me example. Let's transfer what to what. Let's do. Somebody have idea? Give me metric. So let's say meter to kilometer. Let's start with that. So I have meter. I want to go to kilometer. How are you going to change that? One meter is points. Okay, that's right. So one way is if you divide by 100. That's right. So 1,000. So yes, that's right. So you're going to divide by 1,000. That's one way. And another way is if you do, so they give set 2 different ways. So the first way is if I divide by 1,000, which means you move the decimal. And another way is if you have remember the rule I show you, if it's imperial unit, you're gonna use alt unit. You're gonna multiply by new over old. So you can use that also for, so I can cancel the, and the answer is gonna be in the new one. Okay. Let's give me explanation of number 7. Explain the differences between converting 100 feet to centimeter versus square feet to square centimeter. What is the difference here?
You're squaring everything. You're squaring the feet and squaring the centimeters.
Everything have to be square. That's right. That's right. So if you convert, let's do it so you can see exactly how that happened. If you have 100 feet and you want to go to centimeter, what you're going to do? You're going to multiply by feet in the bottom and centimeter in the top, right?
Mm-hmm.
What was the conversion between feet and centimeter? 1 feet is how many centimeter? Oh. How you do that? 1 feet?
Wouldn't it go to inches and then centimeters?
When you do what? 1 foot is how many centimeter? Or you can go from foot to you can go to inch. No, it's not 24. Okay, let's go 1 feet. Let's go to inch. Do you remember the inch? Inch to centimeter?
It's 12 inches to 1 foot.
Yeah, 1 foot is 12 inches, yes. So, and then you're gonna go from inch. Okay, so I have, let me erase that. We're gonna go to inches, right? And then you're gonna cancel the inches down and you're gonna go to centimeter. So 1 inch is how many centimeter? 0.30. Oh, we have meter to foot.
1 inch equals 2.54 centimeters.
1 inch. 2.50. Okay, that's right.
Yeah.
Okay, so if I do that, everything feet and feet cancel each unit, so it's gonna be centimeters. So what you need to do, you multiply 100 times 12 times 2.54. So it's gonna be 3,048 centimeters, right? Now, if you do square, what's gonna be the difference? The difference is gonna be, you have to square everything, right? So you're gonna have 100 square feet. You're gonna multiply by, it's gonna be, again, the same feet. And then it's gonna be 1 foot is 12 inches. And again, 2.54 over 1 inches here. Everything has to be square. So technically, in this case, you're gonna multiply 100. 12 times 12 is 144. And then you're multiplying 2.54 times 250, square that. So that's 6.4516. And what you're gonna get? 92,000. That's right, I get the same 92. Oops, put it backwards. 92,903.4 square centimeters. Okay, so that's the difference. If you square, change square to square, you have to square each unit. So now let me ask you something. What's happening if you have cubes? If you have cubic feet to cubic centimeter.
You have to cube everything.
That's right, you have to cube everything, okay? So keep this in mind, okay? So keep it in mind when you do this on the test, and just keep it in mind in general, okay? Okay, good job. Numbers 8. We're going to number 8. What are the two different methods for graphing a line? So you see, we're going to have questions where they're going to ask you to see if you understand the concept of it. So when you put your answer, you have like answer box where you can just type it in, okay? So use your sentences, just type it in your answer. So can you tell me two different methods of graphing? We talk about two different methods of graphing a line. What they are?
Linear equations.
Yeah, both of those are linear equations. So how you graph linear equation? We talk about
Like the
Mhm.
y equals mx.
Yes, yes. So one of them is slope and y-intercept. That's right, slope-intercept. So if you use the slope and the y-intercept, yes, that's one of them. And another one was what? What was the other method we talk about how to graph it? So one method is using the slope intercept, slope in the y-intercept. And the other one was, do you guys remember?
Was it X1 and like Y1?
That's how to find the slope. That's the formula for the slope. No. With points, yes, which points?
X and Y.
X and Y intercept. X and Y intercept. So using the X and Y intercept. I mean, technically you can say that there is another method of graphing it if you use any point to any 2 points, okay? But this is kind of the easy if you use one of those 2 methods. So let me just go over those 2 methods real quick so you tell me what is the difference, are they similar, and which method you like and why. So if I have, I'm just going to give you example, y equals 3x minus 2. So this equation is in slope-intercept form. And if I have it in this form, it's easy to use the slope and the y-intercept. So looking at this equation, what is the slope? What number is the slope?
The slope is 3.
Yes, the slope is 3.
Mhm.
And which is 3 over 1, right? I'm going to make it as a fraction because slope is rise over run. And what is the y-intercept?
-2.
The y-intercept is -2, that's right. So when I graph this, I'm going to start my line at the y-intercept, which is at -2. That's my first point. -2 is my first point on the graph. And then I'm going to go, slope is rise over run. So what I'm going to do from -2, I'm going to go 3 steps and 1 over. So that's how I'm going to go to the next point. So that's how I'm going to get 2 points. So the first point is at the y-axis -2, and then from here I'm going to go 1, 2, 3 up. So that's at 1 and 1 over. So that point here has coordinates 1 and 1. And these are my 2 points, and I'm just going to connect them with straight line. Okay. So this is rise over run. So you go 3 points, 3 up, 1, 2, 3, and 1 over. And that's my second point. And you can do again 3 up and 1 over, 3 up and 1 over, and that's how you graph it. Okay. But these are the 2 points where you use the slope and the y-intercept. And you always start with the slope, with the y-intercept, and then you do rise over run. Okay, do you guys remember this?
Yes.
Okay, now I'm going to give another example for if you use x and y intercept. So this is the slope intercept method is better if you use the y, if the equation is given y equals, and if the equation is in standard form, for example, 2x plus 3y equals 6, for example, this is standard form. It's easy if you use x-intercept and y-intercept. And the x-intercept and y-intercepts are when x is 0, you put 0 for x, right? This is 0. So you get 3y equals 6 divided by 3, so it's going to be 2. So the point is 0, 2. And then after that, you're going to put 0 for y, and you're going to plug it in again. So when I put 0 for y, it's going to be, this is 0 now. And I have 2x equals 6. I'm going to divide by 2, so it's going to be 3. So those are the 2 points I'm going to graph. 0, 2, and 3, 0. And those 2 points are the x-intercept and the y-intercept. So I'm just going to graph those 2 points. So I have 0, 2. That's one of the points, the y-intercept. And the other one is 3, 0. And just connect the 2 points, and that's my graph. Okay?
Quick
Everybody
question.
remember?
Perfect.
Yes, go ahead.
How did you get 0, 2 for one of them? And then like, well, I understand the 3, 0. That's supposed to be for the y, right? The 3, 0.
Yeah, you replace y with 0 and for x to get the 3. So, okay, let me go over one of those. So let's say I want to do,
Yeah, because I'm confused on how you got 0, 2 for, I guess, the X.
0. The first number is always x. The
Mhm.
second number is always y, right? So when
Yeah.
I replace x with 0, all this is 0. 2 times 0 is 0.
Okay.
Okay, so what's happened? 3y equals 6. I'm going to divide both sides by 3.
Mhm.
And I get y equals 6 divided by 3 is 2.
Oh, okay. That makes more sense then.
Okay,
Mhm.
so that's how you do the y-intercept. And then the other one is the same way. But now you, instead of x, you replace y with 0. Okay? Okay, everybody get that? Okay, so these are the two methods. Now tell me how these methods are similar. What is similar between those two methods?
I guess what
Yes,
is similar is that you basically get the same answer no matter which method you use.
that's right. Whatever method you're using, you're going to get the same graph. That's correct. And also for both of the methods, you're graphing technically 2 points, right?
Mhm.
Yes. Okay, good job. And then how they're different. Or what is different for them? Any ideas what is different? I mean, I can say that the first method, swap intercept, you don't solve anything, you just get the two numbers and graph it. For the second method, for x and y intercept, you have to find the 2 points. You have to plug it in 0, find the other one, then plug it in 0 again and find the first one, right? So it's kind of different way of doing it. Okay, which method do you like more? So that could be individual. So let me know which method you like better.
Slope and y-intercept because you don't have to solve an equation really.
Okay. So if you like the first method, the slope intercept, the slope and y-intercept method, you have to get the equation y by itself. Because
Mhm.
if the equation is not y equals, you have to move everything over and get y by itself and then use that method. Okay?
Yeah.
Okay. Any other question? Somebody else like the other one? No? Okay. Okay, so that was number 8. Now let's go ahead and do number 9. So for number 9, we have the equations equivalent to this equation. There's 2 equations. What information can you get from each equation to draw the graph? So how they're different? This equation and this equation, they're equivalent, but what is the difference between those? This is just exactly what we just talked about. So what is it? What is the difference?
Difference is one of them you have to move everything over.
One of them is y by itself, yes.
Yeah.
Okay. And what information can you get from here? You can get the y-intercept and the slope. Good job. Good job, Zane. So if I have given this equation, the second one, I can find the slope, which is -2, and I can find the y-intercept, right? 0 and 4, okay? Now, if I have this equation, the first one, what information I can get from this equation?
Since the slope is -2, you'd be going down 2.
Yes, you're going down to yes. Okay, so let's just answer what information can you get from each equation. We know for the second equation, when it's y equals, you can get the slope and the y-intercept. How about this one? When the equation, this is called standard form. So what you can get from standard form? You can get what? You can get the x and y-intercept easier.
The x and y intercept.
Okay. Okay, and then how you graph it? If I want to graph, which method you want to use, the first or the second?
The slope.
The slope intercept, okay. So if I want to do that, I'm going to start from 0, 4. It's going to be the same graph in the end of the day, but I'm going to go. Oh, actually, let's move it a little down so I can have room. Okay, so the y-intercept is at 4. So that's my first point. And then I'm going to go 2 down and 1 over. Right? So these are my 2 points I can connect and get the graph. Okay, everybody understand that? Now, if I use the other equation and find the x-intercept and the y-intercept, one of them is going to be 0, 4 also, and the y-intercept, the x-intercept is going to be at 2. Okay, that's the number 9. Any questions on 9? Everybody understand that?
Yes, Professor.
Okay, let's go ahead and do number 10 and 11. These are the last two. So number 10, find the slope of the line. You have given this, use rise over run between the point A and point B. So need to use this specific point A, point B. So what is the slope? Just looking at the graph. You don't have, I mean, you can use coordinates, but you can just look at those points. What is going to be the slope from A to B?
-2.
Because you're going to go down 2, right?
Mm-hmm.
So -2 over 1 over is -2. That's right. Everybody understand that? From A to B is -2 over 1, which is -2. Okay, that's the answer for A. For B, find the slope using the x and y coordinates for point A and C and the slope formula. So for B, I have to use the slope formula. Do you remember the slope formula? So let's get the coordinates of point A. What are the coordinates of point A? What is x for A?
-2,
-2. And what is the y?
5,
-2 and 5. That's right. And what are the coordinates for point C? C is over here.
+2 and -3.
Good job. +2 and -3. So these are the point A, point C. And the slope formula was y2 minus y1 over x2 minus x1. And you can just name each number here we have. So we have x1 and y1, x2 and y2, and you're going to plug it in. So replace the letters with the numbers. Okay, then I already have it, -3 minus 5 over 2 minus -2. That's right. And what is that? What you get from here? Negative and negative make positive in the bottom. So what you have, -8 over 4. And you're going to get the same, -2. So the slope is the same. Yeah, -8. Okay, so we had the same slope, -2, and the slope we get just looking at the graph is also -2. Why the answers are the same? or you get the same answers, the same number for the slope.
Because the x coordinates is -2 and so is the slope.
No.
Um,
Why does? Because the slope is constant. Good job, Aliana. So every time you have a line, straight line, the slope is the same number. It doesn't matter which points on the line you're gonna pick, okay? So you can get the slope from A to B, or you can get the slope from B to C, or A to C, doesn't matter. Any 2 points on the same line are gonna give you the same slope, okay? The slope is a constant number for each line, because here we're talking about the same straight line. It's the same straight line going to A, B, and C. So it doesn't matter if you pick A and B, or you pick A and C, these 3 points belong to the same straight line. And every straight line has a slope, which is a constant number. It's the same for every line. So every line have a number, which is the slope. And the slope doesn't change which points you're gonna use on that line. Make sense? Okay, good job. Some of you got it right. Okay, so that was number 10. Any questions about that? Okay, let's talk about 11. Okay, they give me f of x equal -5x plus 20. Describe the difference between f of 0 and where f of x is equal 0. So this is important question. So do you understand what is f of 0? What that means, f of 0, that's functions. We talk about functions. What f of 0 means? Plug it in 0 for x, that's right. So f of 0 means you plug it in. What f of x equals 0 means?
The y equals 0.
Good job. F of x equals 0 means the y is 0. So here you're gonna solve function equals 0. Okay, so let's do the f of 0. F of 0 is gonna be -5 times 0 plus 20. You replace 0 for this x. And -5 times 0 is 0, so it's gonna be 20. 0 plus 20 is 20. Now, that's how you plug it in, okay? So f of 0 is gonna be 20. Now, if I wanna find f of x equals 0, where f of x is equal 0, I need to solve the equation. I'm gonna copy my function -5x plus 20 equals 0. I'm gonna solve it equals 0. So the whole function equals 0. And you're gonna solve this equation when you subtract 20 in both sides, right? The way you're solving any linear equation. So you have -5x equals -20. You're gonna divide both sides by -5. And you're gonna get x equals what? +4. So for the first one, when it says f of number, you plug that number for x, and it's gonna give you a value, one number for y. So when x is 0, y is 20. So that's what that means. The f of 0 is equal to 20 means x is 0 and y is 20. That's a point on the graph. So if you think about this function, if you think about the graph of this function, the point on the graph is going to be 0 and 20. That's the point on the graph. Now, if they ask you to find what is f of x, where f of x is equal to 0, then in this case, x is 4 and y was equal to 0. So that's another point on the graph. And the point is going to be, what's going to be the point? 4, 0. So those 2 points, those are 2 different points on the graph, and they actually have specific name. So any point with 0 for x is called what? What kind of intercept is that?
Y-intercept.
Good job, that's the y-intercept. And any point on the graph when y is 0, it's called
X-intercept. Oh,
x-intercept.
sorry.
Very good
Yeah.
job.
You got
Yeah.
it.
Good job. So you found here, this is the way to find x-intercept and the y-intercept also. I'm just adding this so you can see what difference that makes, okay? So pretty much that's what's gonna help you with the review. That's gonna be the review for the exam. Any questions? Let me know.